12.6, which is motion of a projectile Okay, so we're only going to look at 2D motion here, where motion is in the plane. We're not looking at the third dimension, which is in this case coming outside the plane of the paper. So let's say that you launch a ball under gravity with a velocity v0 at an angle theta with respect to the horizontal, and gravity g is acting vertically down. Okay, so under the influence of gravity, the particle follows a parabolic profile. Okay, so the horizontal, so what we can do is we can write the acceleration as minus gj, right, where g is gravity. Okay, so the acceleration is constant, it's in the z direction, negative z direction. The reason I wrote minus there is because my y-axis is pointing upwards, that's positive, and downwards direction is negative, that's why there's a negative sign. So in order to analyze this motion, I'm going to split it into two parts. I'm going to analyze the horizontal motion along the x-axis. So the acceleration in the x direction is 0. So the velocity is, let's find the velocity. So dvx dt is 0. That means dvx equals 0 dt, which is 0. So vx is basically a constant, right? Acceleration is 0, means velocity is constant. We know that at time t equals 0, the velocity in the x direction. So what's the velocity in the x direction? If I told you that the velocity is v0 acting at an angle theta, what's the velocity in the x direction? This is simple trigonometry. That's v cosine theta. So v0 cosine theta. So the velocity in the x direction is a constant, v cosine theta. The next thing we want to do is find the position as a function of time. So vx is dx dt equals v0 cosine theta. So integral dx is equal to integral v0 cosine theta dt, and the integral of that thing is x equals v0 cosine theta. Now v0 is a constant, theta is a constant, so it's only integral dt, that's t plus c2. What we know is that at time t equals 0, the position is, well, I've shown that position is x, 0. So x equals x0. So if you shove in t equals 0, x equals x0, then you get c2 equals x0. So the position as a function of time is x equals x0 plus v0 cosine theta times t. That's a key formula. The velocity is a key formula. Okay, so you do not have to remember these formulas. You can derive them very quickly if you know what the acceleration is. But it doesn't hurt to remember them. I posted a formula sheet. Let me see if it is in the formula sheet. So if you go to Blackboard, I've posted the formula sheet which we'll be giving in the exam. If it's in that sheet, it's there in the given in the exam. Yeah, I think it's, well, we give you the formula for motion under constant acceleration. So if you put A equals G, you should be able to get that. So in effect, we give you the formula. Okay, so any questions on this? We're going to do the same thing in the y-axis. I'll do that very quickly. So let's do the same thing for vertical motion along the y-axis. Vertical motion. So what we know is ay is minus g. So ay is dv by dt equals minus g. So we integrate this. dvy equals minus integral g dt. So Vy equals minus gt plus c3. At time t equals 0, we know that the velocity in the y direction, so velocity is v0 and the angle is theta. So if you use trigonometry, the velocity in the y direction is v0 sine theta. So c3, so if you put t equals 0, you get vy, and vy equals v0 sine theta, then c3 equals v0 sine theta. So Vy is minus gt plus v0 sine theta. Okay, we also want to find how the position changes as a function of time. So Vy is dy dt equals minus gt plus v0 sine theta. I'm going to take the integral dy equals minus gt dt plus integral v0 sine theta dt. So this gives me y equals the integral of t is t square divided by 2, so it's gt square divided by 2 plus v0 sine theta times t plus a constant c4. In order to find c4, we need to know something about the initial position. We know that time t equals 0. The initial position of the projectile was y0. So going back, t equals 0, y equals y0 gives me, in fact, I'm putting t equals 0 here, so c4 equals y0. So my formula for the position is y equals y0 plus v0 sine theta t minus half g t square. Okay, any questions on this? I hope you guys are reading the textbook. Yeah.
Earlier on, how did you get C3 equals V naught sine theta?
Yeah. So what I did was, right here, I put Vy. So I subbed in the value of this values in this equation. So I got V0 sine theta equals minus g times 0 plus c3. So c3 is v0 sine theta.
So you just put
Yeah, you put
C.
right. So that's how you compute. You do the same thing over here to get c4. Any other questions? Okay, please read the textbook, because what I'm doing is just a small part of the textbook, and textbook really does a better job because, well, I only have so much time to do theory in class. Okay, so let's try to apply what we've learned. Basically, these 4 formulas which are highlighted in a problem.
You show like the last problem.
Sure. Okay. Okay, so let's read the question. Well, it's kind of self-explanatory. A ball is thrown at an angle of 30 degrees, okay, and it's it enters the basket, as you can see, and you're given all heights as shown. You got to find the velocity A. So the launch velocity if the ball enters the basket, and then you got to find the velocity when the ball is passing through the basket. So you have to find velocity at B, which is velocity at B is unknown. So what you know about this problem is you know the coordinates of the basket. You know where the ball is going to hit. So let's see if we can use that information. You know something about the position, so I'm going to use the position formula. So one of the formulas which we derived just a while back was x equals x0 plus v0 cosine theta times t. Right? The other formula we derived was y equals y0 plus v0 sine theta t minus half gt square. Okay, so normally you're given the velocity and told to find position. This is an inverse problem where you're given the position, the final position, initial position, and it asks to find what the initial velocity is. So I'm going to put the final position of the ball on the trajectory. So the final position is, in this case, when the ball is inside the basket. I need to choose a origin. So this is my origin, 0, 0. So the final position, the x direction is 10. I'm trying to use this formula. The initial position x0 of the ball, this is when the ball is in the at point A is 0, right? This is the beginning of x-axis, plus v0 is actually VA. Cosine of theta is given to us, it's 30 degrees, and t is the time. This is the time from here to time t equals t over there. So time t is measured from here. That's the time t, which is an unknown. Yeah. Absolutely. Absolutely. If you want to designate this as the origin, you'll have to make the changes in x and x0. That's fine. I'm just trying to use this because, oh, I see. This is why you're saying it. They're given x here and y here. That's why you want to use, yeah, so I assume that this is the x-axis. And assume this is the y-axis. I did not see this. But you could assume that that is 0, 0, absolutely. Yeah, you just, right. So then the second formula, y, the y position over here of the ball B from the origin is going to be 3 meters. The initial position at A is 1.5 plus V0 sine of 30 degrees times t minus half times g. Now g is given to you normally. In the exam we'll give it to you. It is 9.81 meters per second square. So 9.81 times t square. Okay, so what we have here are two equations, and those two equations have two unknowns. The two unknowns are two equations, two unknowns. The two unknowns are VA and T, and the simple rule in algebra is that if you have two equations, two unknowns, you should be able to find the two unknowns. So I will not take the effort of solving for those unknowns, I just give you the answer, but essentially you can change the answer. This is VA. What I would do is I would take VAT from the first formula and put it in the second formula and solve for T first and then get VA. So if you solve this, what you get is VA equals 12.36 meters per second. Okay, the second question asks you to find the velocity at B. Okay, so if you're asked to find the velocity at B, clearly the velocity has got two components. There's one in the x and the one in the y direction, and so you got to use the other formula which I derived in the class. The velocity in the x direction is v0 cosine theta. The velocity in the y direction is, oh, by the way, when I did this previous question, I could also solve for the time. That's the second unknown. I should write this down because I'll need it. So the time was found to be 0.9339. Okay. Moving to the second part, Vy. If you go back to the formulas I derived, this formula is V0 sine theta t minus, V0 sine theta minus gt. Right? So in order to find the velocity at B, so velocity, I'll write Vbx to make it clear I want to find the velocity at B, equals Va cosine of 30 degrees, right? I know what Va is, it's 12.36 cosine of 30 degrees, and Vby equals Va sine 30 degrees minus Gt, that's 12.36 times sine of 30 degrees minus 9.81 times 0.93. I'll write it as 993. Okay, so you can solve for Vbx and Vby. Vbx, what I get is 10.7 meters per second, and Vby equals 2.97. So see that the velocity in the y direction at B is negative, which means that the ball is going downwards. Right? If it was positive, it would go upwards. So the net velocity at B is square root of 10.7 square plus 2.97 square, and that comes out to be 11.1 meters per second. Oh, so it's just before it hits. So we're going to come to the point where we analyze collisions. That's somewhere in chapter 17 or something. But yeah, it's asked before it strikes the boat. Any other question? Velocity in this case is horizontal. You're going to find the velocity or the horizontal velocity if the ball just clears the fence or clears the wall. And then you have to find the horizontal distance s that the tennis ball will fall after clearing the wall. So again, this is, as I said, it's a similar problem like previously, because you're given the initial and final position and you're told to find the velocity. If the inverse problem is you're given the velocity and told to find the position. So we use the same philosophy or the formula we used earlier. We know the positions at A and B. So I'm going to write this. I'm going to write the formula slightly differently. I'm just going to write in terms of A and B. So x B is x A. So I'm subbing in x equals xb and x0 equals xa from the previous formula, plus VA. So VA cosine theta, right? Times t. So what is the angle made by the velocity with the x-axis? It's 0. So cos theta is 0. And let me write the formula for YB first. So YB is YA plus V A sine theta t minus half gt square. So theta is 0, that's right. XA, so I need to fix a coordinate frame. So here I've already drawn the coordinate frame. It's 0, 0 is just this point. Okay. So XA is the position of A along the x-axis, and that's clearly 0. YA is the position along the y-axis, and that's 7.5 feet. XB is this point here, B. So that position is what? What's XB? Negative 21. So the key is it's negative because it's along the negative x-axis. And then YB is 3. So subbing all this in the first formula gives me minus 21 equals 0 plus VA, which is an unknown. Cosine of 0 is 1 times t. And the second formula I have YB is 3, YA is 0, sorry, Y is 7.5 plus VA. Now sine theta is 0, so this is going to be 0 times t minus half gt square. Okay, what's g in feet per second square? It's 32.2. Okay, you do not have to memorize this. We'll give it to you. If you have not given it to you, just ask us and we'll tell it to you. So the good thing about this particular problem is that that term cancels out, which means that from the second equation you can solve for the time.
How do you get 32.2?
It is 30. Is it 32?
Yes.
My bad. 32. 32.2? Okay. Okay, so how did I get it? Well,
Okay.
that's just gravity, yeah. If I were to do that, I have to spend a lot of money, buy experimental setup and verify that gravity is, but you can actually do it with a camera. There is a software where if you drop a ball, it can do motion tracking and then you can figure out how fast it falls and into it. But you don't have to do that. Take it from me, it's 32.2. So from this equation, you can solve for the time. It is 0.53 second. And once you shove this time in the first equation, you get VA equals 39.6 feet per second. Okay, so I have just a minute more. Oh, I'm past time. Okay, so I'll solve the second part, which is finding S. But given the velocity, what you need to do in order to solve for S is that you know that